You know, it's been said that we have long-term plans, and all the corporate boards, and you know, those help us make decisions. Well, our next speaker works for a corporation, Toyota, that has a 200-year plan. Imagine standing up and presenting your 200-year plan for transportation and the business. Toyota is, in my mind, a leader in transportation. Their unprecedented growth of where they're going. Did you know that Toyota has a housing division? And I think I'd like to be thinking about the systems opportunities. As we've just heard Alan talk about the trains, as we develop cities, because if you look around how Phoenix and other large cities are going to grow and expected to grow from the retirement boom, how should this transportation and development bleed out in the future, and what opportunities do we have there? And whether we go to a hydrogen economy or something else, it'll be very interesting to see how the industry responds. Justin Ward is an engineer with Toyota's Advanced Technology Vehicle at Toyota's Technical Center in California. He's been working at TTC for the last 6 years. His focus has been on fuel cells and the challenges of getting them to market. Please welcome Justin Ward.
Well, thank you, everyone. Thank you for coming and giving me this opportunity to talk a little bit about the status of Toyota's hybrid technologies. Now, I won't give you too much details about fuel cells because that's a little bit further down the road, and I think most of you are more interested to see kind of the pathway for sustainable mobility from a bigger picture standpoint. So why don't we go ahead and get started. The first thing we need to understand when we're looking at the automotive industry is what drives change. What are the things that really kick us off in the transportation industry? And those are the globalization of our industry. I mean, Toyota's not just a Japanese company anymore. We're a global company. The same is true with GM and Ford. We're all global industries now, making global vehicles and global products. There's a dramatic increase in population and vehicle numbers. You combine that with an accelerated consumption of fossil fuels, and you end up with these three main powertrain drivers. And that's energy and fuel diversity, carbon dioxide reduction, and lower exhaust emissions, or air quality. And I'll try to give a snapshot of these three things real quick. First is energy and fuel diversification. You guys have been talking about this all week, so I don't have to go too much into this. This is just kind of a snapshot of what we think is the fuel and energy diversification is going to look like. And it's going to diversify. It's going to have to diversify to support the growing needs of our planet and the growing needs of our developing countries. Carbon dioxide emissions. There's a lot of talk about carbon dioxide emissions, and it's a very important thing. If you look at this chart here, I believe it's on your left-hand side, that's a data that I've taken from Dr. Lewis at the California Institute of Technology, and it shows that over the past 400,000 years, there's been kind of a cyclic trend in carbon dioxide in our atmosphere. So that shows that we have our ups and we have our downs. Well, the thing I want to kind of point your attention to is on the very right-hand side of that, there's a little spike. Let me blow that spike up for you. What is that spike? If you look at this time scale, that shows that since the Industrial Revolution, we've had a dramatic increase in the amount of carbon dioxide in our atmosphere. So yes, the planet does go through normal cycles of carbon dioxide, concentrations going up and down, but yes, we're also in a condition where we've had a dramatic impact on our planet. What does that mean? Well, now we need to understand where does all that carbon dioxide come from. If you look at the IEA report in 2004, there's newer data, but this kind of is a good summary. It shows that when this summary was done, transportation accounted for about 21% of the carbon dioxide produced or released into the atmosphere. Well, the key thing I want you to notice on that pie chart is it's not just transportation. It's industry, it's residential, it's power generation. It's a global issue, and we need global initiatives across all sectors to be able to address carbon dioxide issues. So when you go home tonight, consider getting those high-efficiency light bulbs. Because if all of us can drop 1 or 2%, imagine what 6 billion people can do. Air quality is the next thing. This is some numbers I've gotten from the US EPA, and it shows that vehicle miles traveled has gone up dramatically since the early 70s. Energy consumption's gone up, our population's gone up, but our aggregate emissions has actually gone down. So we should be really excited about that in the United States. We've actually made this positive impact. But is it really positive? Well, if you look at a quote from the US EPA, it says, despite great improvements in air quality, over 100 million people in 2006 lived in areas that didn't meet air quality standards. That's a big deal. We've made improvements, but we got to keep making more improvements. How do we do that? Well, at Toyota, we feel strongly that hybrid technologies is a way to really have a dramatic impact on those three drivers. Today, we sell 6 hybrid vehicles on the market. We have our Prius that you probably all know. We have our hybrid Highlander, our hybrid Camry. We have our Lexus line of hybrids, which include our RX, a GS450, and our LS600H. I think that was referred to as a behemoth earlier this morning. The thing to understand about the LS400H is when you compare it to vehicles in its class, like there's another car company starts with a B, ends in a W. If you look at the emissions of that car, it's called a LEV emission, low emission vehicle emission. That is the dirtiest car you can sell in California, dirtiest level. This is a SULEV, it's a super ultra low emission vehicles. You got to really kind of put things in perspective when you compare these with cars in their own class. To understand how hybrids fit or if they make sense, you really have to look at it from a life cycle. And we do this with all our products. And that's how we measure sustainability. And we take everything from the manufacturing of the raw materials all the way down to the recycling and disposal of the car. When we do this assessment with our Prius, what we found out is in nearly every category, we have a pretty dramatic improvement in the emissions, the lifetime emissions. But you do notice there, second one up from the bottom, we do take a hit in particulates. Now, as with any kind of maturing production technology, we're expecting to drop that number as well as the other numbers down. But the key takeaway from this slide is that the total emissions components are far less than a conventional vehicle. So what about plugins? How do plugins fit in? You guys have one in the lobby over there. You know, there's a lot of media buzz about plugins. How do plugins really fit into this scheme of sustainable mobility? Well, there's some interesting things about plugins. You know, you can recharge them from your house, which, you know, that could be a benefit to your bottom line. It has a reduction in carbon dioxide, potentially. You can save some fuel. You know, it's pretty quiet when they're running. So there's some kind of benefits to a plug-in technology, and everyone wants to see how far we can push that technology. But there's some things you need to understand when people talk about plugins. Some companies talk a lot about the all-electric range plug-in, or the AER. They talk about a 40-mile all-electric range. That's basically an electric vehicle with a little small gas engine to act as a range extender. Some companies like GM's Volt follow that kind of design strategy. Toyota's plug-in vehicle uses a different strategy. We use a blended mode. And a blended mode hybrid basically has the same type of operation as our current hybrid, but we have a much larger battery pack. And you'll probably be surprised to find out that there's many benefits in going to a blended mode while still retaining all the positives you get from an all-electric. And I'll go over that a little bit more later. One thing to consider is the size of the battery. Like, how big really does a battery have to be? This was a study done by NREL back in 2006. And it shows that following this particular drive cycle that you can have about half the amount of battery you need going to a blended strategy. Now, when you start to consider how much energy it takes to make the battery, what raw materials go into the battery, how do you recycle that battery, having half of it starts to add up. When you start looking at it from a customer cost, if you have half the amount of battery, that's about half the cost. So you have to really consider that when you're developing these vehicles for a mass market, for a global mass market. So with that, I'm already kind of leading into the challenges, but what are some challenges for plug-in hybrid vehicles? And, you know, again, they have the positives, they have some benefits, but you got to really understand what the challenges are that are still remaining. There on the left-hand side is our current Prius. You can see the battery takes up some amount of space in the luggage compartment. We have it under the floor, so you don't really notice it. So now we're kind of predicting far out, like 2015 battery technology. So we're taking what today's PR announcements are from battery technology, and we're extrapolating that to future achievements in 2015. So with that kind of consideration, improved batteries compared to what's being announced today. A blended mode, you may be able to get the same kind of volume as the current battery pack in a Prius with benefits in new battery technology. Now, if you're looking at a 40-mile all-electric range or AER style, you're going to find you're going to consume a vast majority of your passenger space. Now, for some niche markets, some small markets, that may be acceptable. But for most of us, we want to be able to put groceries in the back of our car. We want to be able to take our luggage to the airport. So that kind of strategy doesn't necessarily work. The next thing we need to also understand is charging time. Because if you're going to have a plug-in, you're going to have to plug it in. And how are you going to do that? Well, in the United States, most people are looking at using 110 or 120 volt outlets, the normal outlets, because that makes sense. Everybody has a normal outlet in the garage, or nearly everybody. Well, most of those are on a 15 amp breaker, so you can get about 12 amps out of that. So maybe in a perfect scenario, if you have a blended mode hybrid, you can get about 2 hours charge time. Now, that's pretty reasonable, so you can come in late and still get a full charge on your battery. Now, from a 40-mile all-electric range type, if you're going to plug into that 110 outlet, you're going to need 6.5 hours to charge your battery pack. And that's remarkably similar to the charging time it takes for the RAV4 on 220 volts, RAV4 EV that we had back a long time ago. So when you look at this big battery plug-in, does it really make sense from a charge standpoint? Is the customer going to be willing to accept a 6.5 hour charge time? Or are we going to force the customer to install new infrastructure in their garage so that they can drop their charge time down? Now remember, for those of us that own houses with garages, maybe that's not a big deal, but people that live in big cities and need to find power to plug their cars into, finding 220 volts may be a little bit tough. Next is carbon dioxide. Everyone talks about the big benefit going to plug-ins from a carbon dioxide standpoint, but let's see how it compares to a Prius, because a Prius does really good at dropping carbon dioxide compared to a gas car. Well, you've heard a lot about China already this morning. So if China plugs in and we use their electrical grid mix, what we find is you actually hurt your carbon dioxide emissions. You make it worse by going with a plug-in. When you look at the US average grid mix, you can see there is a benefit, although I can barely see it on that chart. Now, if you're used to Minnesota grid mix, it's maybe you look more like China. So Japan's grid mix, because we have more renewables, we use more electricity. You can see it's more nuclear. You can see it's down lower than the US. France, who has much more nuclear energy, has a much bigger benefit from a carbon dioxide standpoint. So remember, it's not just it's not just a matter of plug-ins and plugging it in. It's also how do you get that electricity. And as we move forward, we need to understand how does that play in the market we're trying to put that vehicle in. But carbon dioxide is one component, right? It's just one component. There's other emission components that we need to understand. And this chart is one that we had done by Kreider and Associates. And I want to draw your attention to the circle there at the bottom. That's the Prius. And this is a lifetime emission of the Prius. We're looking at carbon monoxide, carbon dioxide, non-methane hydrocarbons, NOx, particulates, sulfur oxides. What you notice there, these are 20 kilometers and 60 kilometer plug-in hybrid designs. When you look at those designs and you account for the total emissions on the grid, if you look at a California grid mix, which is the clean grid mix, you'll see that even on a 20-mile all-electric range, you have actually a negative impact on your total emissions. So when you're looking at plug-in technology, you're reading all these press releases about the benefits, make sure you read between the lines, because it's not just the car. The car is one part of the solution. You can get a lower carbon dioxide emission, but it's only one part of the puzzle. Something else feeds the car, and that's the grid. We have to make sure that the grid is appropriate. Otherwise, you're not going to get the big benefits that you want to have. So how do we wrap all this up together? Well, we have our vision for the ultimate eco car. You've seen this chart probably before. And the ultimate eco car, it sounds kind of cheesy, but that's kind of the car that balances the environment, it balances carbon dioxide, air quality. It provides a car at a time when the customers are willing to accept it. And that's kind of the ultimate eco car. It's that perfect balance. How do we get to the ultimate eco car? Well, at Toyota, we're 100% confident that is going to be through hybrid technology. Is it going to be blended? Is it going to be a plug-in? Is it going to be a conventional type hybrid? It's not fully defined yet. Plug-ins offer some benefit, but the other parts of the puzzle aren't in line yet. The batteries aren't really there yet. You've heard a lot of press releases about battery technologies being ready, but they're not. If a lot of these plug-ins today, they have $15,000 worth of battery, these plug-in conversions that are real popular, high motion. But they have very big battery packs. They don't warranty them very long. How do they last for the life of the car? And if you look at studies done by A&L, you'll actually find their tailpipe emissions are worse than a conventional Prius. So where's really the benefit? So don't always believe all that hype. Try to look a little bit deeper into it. But we do feel the hybrid technology is going to be the enabling technology to get us there. And the format of that is, we're still working on it, but we feel we're getting close. But let's get a little bit about automotive history. They've talked about it a little bit today. When you look at kind of the history of automobile, you can see we had some EVs that didn't quite make it long before Who Killed the EV movie came out. And you can see that it took about 27 years really for the gasoline-powered vehicles to really be mainstream in the global market. 27 years. So that's a kind of a time scale to keep in mind. Well, a lot of people say, well, that's a long time ago. That was before technology. What about, you know, if new technology came today, things would be different. Well, let's see if I can move. Here we go. This is the sales of our Prius. Now, maybe most of you won't deny our Prius has been kind of a runaway success. It's kind of, a lot of people use it as a focus for market studies to kind of understand how vehicles are going to enter the market, how do they grow into the market. We sold 1 million hybrid vehicles earlier this year. I mean, it was a great milestone. We're all really excited about that. But it was 9 years it took for us to reach 1 million vehicles, 9 years. And you know how much 1 million vehicles account for in the global market? Less than 1%. It's about 0.2%. So it took us 9 years to get to 0.2%. With technology, we were real confident was going to make it. So I want you to keep that in mind as we look at these technologies. As you hear press announcements about plug-in technologies, if there is a magic battery that's ready today, that we can put in a car today, look at this time scale. It's going to be a while before the vehicles are actually deep into the mass market and have an impact on the global economy. And with that, thank you all.